I've been using Pandas for a number of years. I've been teaching Pandas for a number of years. And one of the things that people sort of don't know in my experience about Pandas is how it works with dates and times. Like people know it works with numbers. People sometimes know that it works with text, but dates and times are a little surprising to people. So that's what we're going to be talking about. So the first thing I want to talk about is just like, dates and time, concepts and data structures. And we're going to talk about that very, very briefly. But then what I want to talk about is timestamp columns, right? And how to read them. And that means basically, as you'll see, when we read data in from a file, especially a CSV file into Pandas, how can we tell Pandas that this contains date and time information? And why would we really care? And what sort of effect does that have? Okay, so let's see here. Oh, I see that there's like a chat going on. Let me go back there. Oh, perfect. All right, and then basically, let's see here. I'm just like gonna put this so I can like see what's going on in the chat out of like the corner of one eye, in addition to everything else. Come on. Oh, maybe I can't see it. Okay, maybe I just don't know how to use this chat system. All right, well, I'm sure I'll figure it out at some point. How hard could it be, right? All right, so let's see here. So then we're going to talk about time delta columns and what they are and how to work with them. And then I want to talk about date time indexes on data frames and how that can work. And it is not an Apple II back there, but it is a Mac, I think from like 1984, 1985 that I bought from someone secondhand, like 1995 or so. And then time series and resampling, which is like the coolest thing from this. Okay. Oh, and I am, by the way, in Modi'in, which is a city halfway between Tel Aviv and Jerusalem. Okay. So let's first talk about date and time concepts, because this, when I first started programming and when I first started using dates and times, I didn't quite understand how all this worked. And now I have a much firmer grasp, but it took a long time. And so when we talk about time as human beings, we're like, oh, this is happening, and your birthday is in such and such a date. Or like the meeting will start at such and such a time, or the meeting is being pushed back by 10 minutes. Or like the meeting will take 2 hours, heaven forbid. But basically, these are all different ideas. And we can basically talk about time and date concepts. There are basically two of them. We can have one moment in time, and then we can have a span of time, not a spam of time, a span of time. So, and that would be when the meeting starts or when you were born, right? And a span of time is how long the meeting goes or how long you have been alive, right? Hopefully continuing for a very long time, at least through the end of this talk, right? Unless I bore you to death. All right, and so basically in Python, we talk of this as a timestamp or a DateTime object. And so this contains a, or I should say, representing one moment, one specific moment. Whereas a span of time doesn't have a specific start or end, but rather is a length of time. And this is known in the Python world and many others as a time delta, right? So basically, a timestamp is year, month, day, hour, minute, second, and that never changes. It's anchored in time at a particular point. So it can be in the future, it can be in the past, it can be the present, but for a very short time. A span of time, though, a time delta, is basically, right, it's 1 hour long, it's 30 seconds long. And once you sort of realize that we can separate these two and have to separate these two, this really, really comes in handy. And we're going to come back to this again and again and again. So let's actually talk about how this works with pandas and how we can work with it. So I'm going to just load up pandas here. So I'm going to say here from, well, I'm going to say import pandas as PD, and from pandas import, just bought a new keyboard, so I might get things a little data frame. There we go. Okay, and now I'm going to load up one of my favorite data sets to use. So as you know, a whole lot of cities around the world, why is this taking so? There we go. A whole lot of cities around the world now make their data available publicly, and New York is one of them. And while for my book, for Pandas Workout, I'm actually using a newer set of data from New York City taxis, I have an older, shorter set that I've been using from, like, I think it's 1995, 1996. We'll see in just a moment. So I'm going to create a data frame based on this. And this is like an amazing thing that basically, when I was growing up, and while I'm in Israel, I grew up in New York in the suburbs. And when I would go into New York City to take a taxi, like, my parents taught me how it works. Like you tell the driver where you want to go, and you get there, and you find out how much it is, and you pay, and you give a tip, and then you get the receipt. All good. Nowadays, of course, it's all computerized. You can use a credit card, and the computer that people think of as allowing them to pay is actually also tracking them in many ways. The computer is figuring out where they started, where they ended. The driver has to enter how many passengers there were. But it's really keeping track of all sorts of different stuff. And that data is all made available publicly from the New York City Transit Authority, their data authority, whatever it is. So what I'm going to do is I'm going to say here, df equals pd read CSV. And I'm going to say here, taxi.csv, which I've conveniently plopped into the same directory as I'm located in, and is also in that GitHub repo, by the way. So if I now say df.head, let's take a look at all the columns I've got here. And it's going to be a whole bunch of columns. So I've got the vendor ID. That is what company made the computer in the back. They're actually two different companies, as you can see, 1 and 2. And cute little story, they actually used to calculate the tip differently, including and excluding tolls. So this was revealed by a data scientist in New York, and within a few weeks they changed it so they both did it. We have the pickup date time, the drop off date time. So when did the cab ride start? When did it end? How many passengers? How far did they go in miles? The longitude and latitude of the pickup, and then like rate code ID, drop off longitude and latitude. By the way, in newer versions of the data, the longitude and latitude of drop off and pickup are no longer there. Maybe because someone realized that this was like a violation of privacy, maybe because you could figure all sorts of things. But while this was around, you can be sure that it could be used for all sorts of interesting tracking. Like, let's say I'm a data scientist who's moonlighting as a taxi driver in New York. You never know, all things are possible. I could figure out where the most popular locations are for pickup at certain hours. By the way, I'm 100% sure that companies like Uber and Lyft did exactly that, mining that data. And then like how much is the fare amount, the tax, the tips, the tolls amount, improvement surcharge, and the total amount. So all this is very nice and interesting, but I actually only want to load up a few of these columns. So I'm going to like restrict it a little more. So I'm going to do this. I'm going to say here, df equals pd read CSV of taxi CSV. And I'm going to say here, use calls equals, and I'm going to say here, tpep pickup date time. By the way, tpep is like the taxi something, something, something. It's like the official New York taxi for like data stuff. Drop off date time. And then we'll bring up, trip distance. This is like my favorite column to have around here. And passenger count. And let's do total amount also. Okay, great. So now I've read in only like 5 columns there, and that's fine. And we see these columns, and we say, aha, we have date and time information in these first 2 columns. And then, as you can imagine, we have an integer, and then we have floats here for the trip distance and the total amount, right? Not exactly. Because if I say df.info, which tells me about the data frame, I'm going to find out what types we have there and some information about it. And we see that in my data set. And again, this is like a very non-representative sample. But in my data set, I basically have here 5 columns, but you can see that these first 2 columns are just object columns. An object is Panda's way of saying these are Python objects. I don't know what to do with them. I'm just going to sort of like hand it off to Python. And typically that means they are strings, which means if you want to do string operations on these things, that's fine. But if you want to do actual date time operations, not so fine. So what are we going to do? Well, we could cry, right? But we can also tell Pandas that we want to load things up in a different way. We want to interpret those columns as date and times. And so what I'm going to do, actually, let me just show you this for a moment. This is like one of my favorite things, that Pandas has incredible documentation. So if I say help on pd read CSV, oops, well, except they have to spell it right. Yeah, CSV. There we go. Come on. Let's try this once more. There we go. And you can see that there's like a crazy number of parameters that it accepts. And one of them is parse dates. And parse dates here equals false. That means there are no dates that we want to parse. But what I'm going to do is I'm going to say here parse dates equals, and I'm going to give it the names of my 2 columns that have dates. tpep pick up date time, and tpep drop off date time. And now if I do that, it loads it all up, all is good. And now if I do a df.head, it looks almost exactly the same as before. Ah, But watch this. If I say here df.info, now I'm going to get, look at this. Now my first two columns are actually date time 64. Fantastic. Now they are actually 64-bit date time systems. So we can actually keep track of date times and all that other good stuff. Fantastic. By the way, if you're saying to yourself, how did it actually read this in? Like, how did it know how to interpret the dates? The answer is, of course, magic. No, not magic, right? I'm wearing short sleeves. I can't do magic. Basically, what's happening is it thinks that it knows how to interpret them, and usually it's right. But there are also sort of hints you can give it. And one of them, right, in the US, of course, you say month/day/year. And in Europe, you say day/month/year. And in Asia, you typically say, right, year, month, day. So year, month, day can handle just fine. But you actually have to say day first equals true or false to indicate whether it's an American date or not. Okay, so what can I do? How does that help? Well, here's the thing. Once I have that, now I can actually start to perform operations on it. And how am I going to do that? Well, if I were using like plain old Python, then I would like want to run a method on my DateTime object to extract something. But in order to do that in Pandas, what am I going to like run a for loop? No. You run for loops, bad news. For loops in Pandas always bad. Instead, what I want to do is have something apply the appropriate method or the appropriate sort of extraction system to it. And the way that we do that is we can say here, watch this, df of tpep pick up DateTime. And that's going to return all these dates and times here. And look, once again, it's a DateTime 64. What I can do is say df tpep pick up DateTime dot dt. And dt is short for DateTime. And I call this like a proxy object. That basically I can now run a method on this proxy object and it will be run to each of the individual elements. So I can say dt of hour. And now we get out the hour from each of these. Or I can say something like day of week. And then I get the day of week for each of them. Or I can do all sorts of stuff, right? I say here, like, I think it's like, is leap year is one of them I can do. And it'll say, false, 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 all in the same year. There are all these different things that you can retrieve from this date time accessor. And so I can say, for example, date time hour, and then I get a series back indicating what hour it was at. And then I can say date time hour value counts. What is that going to do? Well, it means go to the pickup date time column, pull out the hour, and then calculate how many times each hour was there. And we can see then just how non-representative my data set is, because it says that 4,300 of these were at 11 in the morning, 2,500 of them were at 3 in the afternoon, 2,400 were at midnight, and like 600 were at 4 p.m. By the way, here's a little cool trick as well. Oops, I always keep telling you, like new keyboard, I keep like mixing up which is like alt and which is everything else. So if I like pull this out, I can also say, this is like a cool little feature, I can say normalize equals true. And then it will show me the percentages, not the raw numbers. Pretty nifty, huh? I can even, if we're already doing this, I can even say here, oh, I didn't do a Python, well, let's do a PyLab in mine. And that just like makes it possible for me to see like all sorts of stuff in line here. And then I can do this here, and then I can say value counts, I can say plot pi, and then we can see what proportion of the rides in my data set are actually like, from each hour, and it's gonna do it as a pie chart one of these days. Wow, this is like really slow. Okay, maybe I shouldn't have done that and like pushed it to its limits. I'm just gonna stop the kernel here, and then I'll go back and show you other cool stuff. Or not. Oh, there we go. So you can see that. Okay, so that's very nice that I can pull out all sorts of information. And that's great, right? Imagine if you have like a sales report. Imagine if you have log files from your website. Imagine you have all sorts of different things. You might want to pull out that sort of DateTime information. And you can, of course, put it in a new column. So I can say df of like pickup hour equals df of tpep pickup DateTime, right, dt hour. And I can then say something like this. I can say here, let's do this here, like that. And I can say drop-off hour. And say df of drop-off hour. And so now I've added two columns to my data frame, right? We can do a df head here. And then I can find out how often was the pickup hour and the drop-off hour the same. I mean, like not the most fascinating thing to do, but I can say df of pickup hour equals df of drop-off hour, right? And that's going to give me a series. And I can just do a value counts on that. I can find out how often they were picked up and dropped off at the same hour. And the answer is like, what would this look like? 80%, 90% is going to be the same. Again, not the most fascinating thing, but it works. Here's the thing though. These are date time objects. These are objects that give us like specific dates and times. What if I want to know how long each ride was? Well, then I can say df of tpep drop off date time minus df of tpep pick up date time. That's right. You can do arithmetic, and a timestamp minus a timestamp gives us, that's right, a time delta. You can see here I have a series, and the series has type of time delta 64, so it's a 64-bit time. And I can even put that into a new column here, because like we can always add new columns. And now I can do all sorts of things. So I can say df of trip time. Oops, let's do this. Trip time. Great. Now what? Well, now what I can do is I can query those trips that were shorter than or longer than or equal to a certain amount of time. I can say df of trip time equals, let's say, 1 hour. And you might be saying, wait. I can actually use text there. Well, let's find out. Actually, not so much. I think there are ways that you can do that, but I think I'm getting it wrong. Or there are like none that are exactly that much. But what I can do is I can say 00, like 15, 00. How many are 15 minutes long exactly? And there we go. You can see here we have a whole bunch of them that indeed were exactly 15 minutes long. By the way, I think, let me see if I can do this right. I think, I'm always like forgetting exactly. Pandas just does so much. I think I can say 15 minutes here and it'll work. And if not, all right, I'm wrong. Yeah, there we go. So we just had nothing that was exactly an hour. So that's pretty snazzy. Now, the thing is, remember, on the left here, what I'm comparing it with is a time delta object. And on the right, I've got this string. And so Pandas is doing this amazing sort of interpretation here, turning the string into a time delta and then doing the comparison. And of course, I can say greater than, less than, right? So what I can do is I can say df, where df of trip time, right, is greater than, right, let's say 5 hours. Right, and we're going to get, yes, indeed, in my data set, we actually have a taxi ride that was 12 hours long, 12 and a half hours long, right? That's great if you're getting paid by the hour, I guess. Not so great if you're sitting in the back of a taxi for that long. So if you know how to play with these date time columns, you can then create time delta columns, and you can do all sorts of amazing queries, right? So if you're looking at a log file, how many actions on our website took longer than 10 seconds, right? Death. How many orders took more than a month between the order and the fulfillment? How many payments are more than 6 months overdue? All sorts of things that you can do, right? How many users have been using our system for more than a year and yet have paid nothing to us, the freeloaders? But we can go even better than that. We can get all sorts of really cool stuff in addition to that. Because remember that in Pandas, we can set an index. And right here, the index is just going to be the row number as it is. But I can set the row index to be anything, any sort of object. Oops, and it doesn't even have to be unique. Yeah, exactly. hope that taxi driver is indeed moonlighting as a data scientist or vice versa. So I can say here, df equals df set index to be tpep pickup date time. That's right. I'm going to now set the index in this data frame to be the time and date at which we pick things up. The drop-off does have a time as well. Drop-off has time and just a date. It's just a date time object. You just don't always see it. And so watch this. What I've done now is I've changed the index to be this timestamp. And now, as always in Pandas, I can retrieve the timestamp. So I can say df of lock, and I'll say 2015 06 02 11 19 32. And I am able to pull out all the trips that happened at that particular moment in time, at that timestamp. And you might say, okay, that could be a string. It could be a string, but watch what we can do. We can say, what about if I remove the seconds? What if I say 2015 06 02 11 19? It will now retrieve everything that is at 11:19 in any number of seconds. It's a wildcard. Pretty wild, eh? And Hassan has asked the DataFrame indices have to be unique. No, they don't. No, they don't. It was mind-blowing when I discovered this. But DataFrame indexes don't have to be unique. And that's part of the amazing thing. You can pull out information from them. And if there's only one matching row, it'll give you that row as a series. And if there's more than one row, it'll give you a DataFrame back. And that's like part of the power and magic here. So you can think of a data frame as a dictionary, except like there. Also, it like has all sorts of effects on sorting, and has all sorts of effects on like how you can pull things out. So what I've done here is I pulled out everything on the 2nd of June 2015 at 11:19 at any number of seconds. You can keep this going, right? So I can say here, well, I want everything that was, right? Let's just paste this here, and I can say everything at 11, right? And then it's, this taxi ride goes to 11, right? And so now it's going to be everything at 11 hour and any minutes and any and any number of seconds, and you can get as general as you want. So that's something that you can't do in a typical index. Okay, here's another cool thing you can do though, and I see like the time is ticking down, so I'm going to show you this, and then I'll be happy to take questions and go into other stuff if you want. So watch this. What if I think of it this way? I have this data set, and the data set starts at a certain time and ends at a certain time. And I might want to find out how many rides were there per hour during this data set, right? So if I take the earliest possible hour, I take the latest possible hour, and then I take every hour from that start to that finish, and I say, well, how many rides were there in this hour, then this hour, then this hour, then this hour, and so on and so forth. Can I do that? I can do that, because what I can do is I can say df resample, and resample says do exactly that, resample by 1 hour. So what I'm going to say now is resample by 1 hour, and then I can say count how many rides were there per hour from the earliest hour in our index to the latest hour in our index. Now you can see that the answer is 0 for many of them because my data set is so incredibly skewed. So what I'm going to do is I can actually just say here, like count. Well, I guess count won't, I can't really like get rid of the 0 so much. But you can see, I mean, I can get rid of the non-zeros, but fine. I'm just not going to like work that hard there. But you can see I can do this here. By the way, I can also pull out a particular column if I want. So I can say, for example, trip distance. Okay, Khazan, I'd be very, very happy to talk to you about this. Duplicate indexes should be possible. It should be. We can even like expand with this a little bit, maybe during Q&A. And so you can see here that we have now like how many rides were there, or what, how many rides were there in each hour. Well, that's counting the trip distance. Well, that's not very helpful, is it? Right? Why would I want to know the count of the trip distance? But what I can do is I can run other aggregate methods. I can, for example, say mean. What was the mean trip distance for every hour during our data set? Now it gets much more interesting. And of course, now we're getting a whole bunch of nans where there was no data. So I can just do a drop NA there and get rid of those. And now what we see is for every hour for which we have data, what was the average number? What was the average trip distance? Now, here's an interesting little tidbit. I would say right here that we have, look at this, trips that started at midnight went an average of 4.3 miles. Whereas trips that were during the day went an average of 2 point something miles. In other words, my interpretation of this very, very skewed data set, my interpretation is that at night, people take taxis longer, like for greater distances than during the day. Now, is that because they're like, out partying and so, they live not close to where the clubs are? Is that because they're just taking taxis, for work to and from the train station? Not obvious, right? But like, we can start to pull things out about this. I can also pull out other stuff, right? So for example, I can say here, right, what about the passenger count? What was the mean passenger count at different hours? And we can see then, actually, there's no difference, right? The number of passengers does not seem to change, from late at night to early in the morning, right? So basically, people are always very lonely in New York, or lonely plus, plus 1/2 a person. So you can play with this in all sorts of different ways. And now, of course, if we have this sort of, oh, great, so we'll go for another few minutes. So maybe I'll load up the newer taxi data, because that's like bigger, and then we can like really start to sort of look at some pulling off of stuff. So let me actually do that. I'm just going to copy a file here. Hold on just a second. Thank you, folks. All right, let's see here. Sorry, my computer's a little slow. Come on. All right, no, let's do this. All right, if I go to, where do I have the new data for taxi stuff? Oh, I know. Sorry, too many things going on here. It's under the new book thing, managing pandas, workout, data. All right, and then okay, so I'm going to copy. Oh, I know what I'm going to do. I'm going to watch this New York City taxi data from, let's do 2019. I'll put that into courses. Oh, actually, this is a bad. Okay, I'm going to load it up sort of remotely, and the reason I'm going to do that is because I put it into this GitHub repo. Then it will crash, like it won't allow, because the data set is too big to go into a GitHub repo. I discovered that when trying to like distribute stuff to reviewers of my book. So I'm going to say here file name equals users. Oh, come on, Reuven Consulting, Manning, Pandas, Workout, Jupyter Notebooks. Now you see like how organized or not organized I am. Taxi 2019-01 CSV. And here also, all right, and then I'm going to say, I'm going to do the same sort of loading up of stuff as I did before. Come on, come on. Okay, I should have just done this from memory. There we go. Let's do this, and this, and this. All right, and now we just need to make sure to like say file name. By the way, it's always good. Like I like to use a variable there. Okay, let's see if this works. This will take a little bit longer to load up because it has like, this is all of the taxi rides in New York City in January of 2019. And by the way, like in the book, I have a few exercises, a little sneak preview, where we sort of compare 2019 to 2020. I know this might come as a surprise to you, but there's been a little bit of news about this like pandemic over the last year or so. And so one of the exercises I have in the book is like comparing taxi rides in 2019 to taxi rides in 2020. And you'll be shocked to discover that there were many, many fewer in 2020 than there were in 2019. Yeah, I know, big shocker. It's like 90% down. And if I remember correctly, people actually used cash more during the pandemic than less, which was really surprising to me. All right, this is taking a little bit of time to load. We'll give it another few seconds here and be patient. Da, 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 da. All right, it's getting annoying. All right, hopefully soon. Yeah, I knew it was a big data set. By the way, I'll tell you also, while we're waiting for this, let me just load up the Pandas documentation. All right, so like, Pandas documentation here. If I can find like a DT. Oh no, I know where it is. No. There we go, DateTime index. Right, so there are all these different things that you can use. Let's see if I can pull this up on Pandas. Like, and just to know what the things are that you can ask of your DateTime objects. On everything's slow. Okay, so you can ask like, is it the quarter start? Is it the quarter end? Is it a leap year? Is it the year start? Is the year end? And you might say like, why would we have, well, why would we have like these sorts of things? And the reason is that Pandas was basically developed. Wes McKinney, who developed it, was working at like a hedge fund, and so they wanted all these like financial sorts of things. And so if you're working in finance, not surprisingly, then Pandas has all this stuff that you'll want to use to work with it. And in fact, I've heard of a whole bunch of financial institutions that are sort of replacing Excel with Pandas because of like all this functionality. All right, let's see if this is loaded up. Oh, it's still loading. You gotta be kidding me. Okay, all right. I'm just gonna like, sorry folks, I'm gonna like kill this and try once more, and then if it doesn't help, then we'll just like, I'll take Q&A, and we'll hope for the best. Is it now? Did it work? Is it done? No. Go. Do your thing. Dun, 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 dun. How many lines are in this file anyway? I should really find out. I think it's like, oh, is the date parsing taking most of the time to load the data? Arba, that's a great question. I don't know. Actually. I should really try that at some point. I'm guessing it's a very minor thing, because basically it's just loading up a string and then like running some sort of date time parsing on it that like, and Python does that natively, so that's fine. I think it's just because it's like a crazy huge file. Like, let me see how big it is. I'll try it without like, yeah. Well, hold on. Let's do. Oh, come on. Oh, Rimo won't kick us out. Okay, good. Okay, good. I thought you they will kick us out. I was like, oh no. So let's see. Oh, let's just do this here. Just gonna take a quick look. Yeah, that's exactly what I'm trying to do. Do a WC here on. I just needed to like get to that directory on my machine. And we have, oh, come on. So there are 77 million taxi rides during January. And during July. Here, I'll just show you what I brought up here in, watch this. So you can see here that January 2019, 7 million. July 2019, 6 million. January 2020, 6 million. July 2020, 800,000 taxi rides. Like shockingly lower. So yeah. Okay, this is taking forever to load. I think I'm just gonna like give up on it. Sorry, folks, because it is like more interesting data there. All right, let me see if there are any like questions here that people might have. I guess I could have like load this in the background and so forth. You know, here, watch what I'm gonna do. I'm gonna like grab the first million of these and put them into a file. Yeah, that's what I'm gonna do. And let's see if I can play with this for a moment. And while I'm doing that, you can ask me questions. 2019-01 CSV. Maybe that's very funny. All right, any questions while I try to load up a shorter version, maybe? By the way, here's another little pandas hint for you. Whenever pandas goes crazy on you and like gives you an error, so it like gives you the entire what's it called, traceback from the exception that it got. It's like completely crazy how much it does here. If you get an error in pandas, just ignore all of that and just go to the last line, right? And so if you go to the last line here, right, you'll say, oh, you know, error tokenization, calling read n bytes on source. So this actually is not very useful as well. You know, not very useful either, I should say. Oh, I put in too many zeros. It's now trying to load a billion lines from that. Oh, goodness. Not my day for counting. One. There we go. That'll be much better. All right, and then I'll go back and try to load that maybe. You go to the source and look at the pandas test for yourself. Yeah. Please tell me that's a joke. Like, I just don't understand who is going to, I mean, like for the pandas developers, that's fantastic. But like for most most normal humans, I would say, okay, let's see. I now have a shorter version. So let's see if this will load it better. Short taxi. All right, let's load that up because that's only going to be 1 million rides. Yeah, you see, this is like the, you know, the perils of live coding, folks. So I mean, I'll tell you that like once you sort of get into this whole like seeing dates and times. Oh, here we go. Look. So now if we say here like df, let's just do a df shape. So it should be 1 million lines long, yeah, and 5 columns. So now if we try to say like df, right? If I do a df.info, okay, that was like that's good. Df info, and you'll see this is a date time. So now I can say df of tpep pickup date time, and we're going to say here dot dt dot hour, and we can do a value count. Let's see like how evenly distributed the data is here. And this looks way more evenly distributed, right? I don't know if it's like all 24 hours. It looks like it is there, but you can also see, right? In fact, let's do this. Let's do then a sort values, and sort values, of course, is going to take the values and is going to sort them from lowest to highest. And so we can see that the smallest number of taxis are being taken at 4 a.m., 5 a.m., 3 a.m., 6 a.m., 2 a.m., right? But that the most number of taxis are being taken, what do you know, 12, 13, 17, 16, 14, 15, after work. So in fact, more people take them in the afternoon, it would seem, than in the morning to get to work, right? You know, 7, 8, 9, it's getting there, but most of them are then like, you know, afterwards. So maybe it's people come back from work, maybe like the tourists are waking up and so forth, right? And we can actually then, let's see if there is a difference in how we can, like in the amount that people pay or the distance that people go per hour, right? Is there a difference? And now, I mean, I've always heard, I really don't know any taxi drivers personally, but I've sort of heard that they prefer doing the overnight shift because they get paid more. Now, is that because there are fewer taxi drivers out there? Is there a surcharge? It could also be because people on average go farther. Is that true? Well, in order to do that, I'm going to have to extract the hours. So let's do a df tpep pickup date time dt. Oh, let's do this. Yeah, dt hour. I'm going to assign that to df pickup hour. And now what I can do is I can do a group by, right? I can say df group by pickup hour. And then I'm going to say here trip distance mean. And I can do a sort values. So what is this saying? This is saying, hey, pandas, go through our data frame. And I want you to the result should be by hour. I should have 24 results, one for each hour in the day. I'm only interested in the trip distance column. And I want to know the mean trip distance for each hour of pickup. And then take that and sort it by lowest to highest. And what do you know? If we look through this, we find, actually, I don't think there's we see that like the early morning hours here, right? So like 3 a.m., 10 p.m., 6 a.m., 11 p.m. So like, yeah, if you're doing a graveyard shift as a taxi driver, you are likely to get longer rides than elsewhere. But you can also see that like it's not that different, right? Like at 11 a.m. you're getting 2.6 miles, 5 a.m. it's 4.3 miles. Like it's different, but it's not like crazy wildly different. By the way, what if we want to know trip distance and we also want to know let's say passenger count, right? What's the mean passenger count? Well, here's a cool thing you can do. In Pandas, you can actually give more than one column to do the group by on. Not the group, well, you can also do it for the group by, but to get results on. So I can say trip distance. Oops, don't do that. I can say trip distance, and I can also say passenger count. And now I'm going to get the mean for both trip distance and for oops, no, I didn't like that. Why did I not like that? What did I do wrong here? By group by pickup hour. Uh-oh, what did I miss? Oh, maybe I think I can just pass it. That. Yeah. Oh, right. It doesn't like that so much. Oh, what did I do? I think I need to do ag now on this. Oh, maybe. Okay. I'm just going to experiment like a little bit. I could be wrong here. Oh, I know why. Because you have to say, that's why. I think I have to say then ag, and I have to say here, like NP mean and NP mean. I think that's what I have to do. Oh, for crying out loud. Now I'm just forgetting everything. All right. I don't remember. Let me see. Tell you what. Let me just look up in my manuscript where I actually write about these things. Really, I know my stuff, folks. Let's see here. Just got the. Oh, okay. I can do that. Fine. Oh, I see. I can do multiple. Okay. So if I want, okay, I see what I have to do here. Hold on just a moment. This is actually pretty cool. Fine. So I can, if I want to do more than one column, they've messed around with the syntax a little bit. So what I can do is I can say here, I'm going to say ag. Oh yeah, like compare airport hours, public transit. Yeah. Like I always toy with, and I'm thinking of putting this in the book, of like comparing taxis with weather. Like if we see that there's a lot of precipitation, we know that there are going to be like more taxi rides and thus fewer taxis available. But can we see that in the numbers per hour? Right, like all sorts of cool stuff like that. So watch this. Ag is for aggravation, not for aggravation. Aggravation is what I'm feeling. Aggregation is the kind of function that we can use. And what I can then say is this. I can say ag, and I can say mean distance equals, and then I can put in a tuple here, and I can say trip distance, and then I say here mean, and then I can say here, well, let's just do that for now, and then we're going to do one more as well. Okay, so look at this. So we have for each pickup hour, we have the mean distance, but I can add more keyword arguments there. I can say mean passengers, and I don't mean by that like the passengers were mean. I can say here like passenger count mean. And now we get that. And I can even say here something like this. I can say total passengers equals passenger count and count. I think it's count, not sum. Yeah. So now what we can say is for each hour in our data set, what was the mean distance that people went? How many passengers were there on average? And how many total passengers were there? And then, of course, this is a data frame. So we can further sort it, mess with it, and get all sorts of different things. And I love this functionality because what it means is I can apply different aggregation functions to different columns as well, and I can give them whatever names I want, right? So this is the keyword argument here. The name is the name of the column that I'm going to get back. This is the name of the column that we're using for the input, and this is the name of the function that we are applying. Oh, duration of stay at restaurant versus dinner. Oh my God, yeah, like you can just the amount of data that you can mine here is just like more or less infinite.